In the lab, we very often face the problem that we have to pick a solvent, either for a reaction or for chromatography or for a recrystallization, for instance. And the most important advice at first, make a list of solvents that are available. I have done that here, and you should distinguish between unpolar solvents, polar aprotic solvents, and polar protic solvents. Those are solvents that are, of course, polar and have acidic protons, usually at OH groups. So let's go through that list. In the group of the alkanes, pentane is the least polar molecule. Hexane is a bit polar. It has the disadvantage that it is the most toxic one among those small alkanes. I usually prefer petrol ether. It's not an ether with a functional group, an ether functionality. It is the name for the mixture of branched, relatively short alkanes. So then we have benzene. I've put that in brackets. As you know, benzene might cause cancer. And therefore, chemists often tend to change to, for instance, toluene or xylene, but there we have, of course, to face the problem that we have the CH3 group attached, rather reactive, because then the protons are in benzylic position. For instance, in radical processes, they would take part. An interesting solvent is methyl tertiary butyl ether, MTBE. It is produced in large amount within the petrol industry. We can try to use that. We have in my lab already tried to use it for radical reaction. It worked okay. Usually the solvent of choice was tetrachloromethane. However, because of protecting the environment, we are trying to avoid chlorides. Well, let us compare this ether to diethyl ether and to THF, more polar ethers. The unpolarity of that molecule is due to that tertiary butyl group. So these ethers are usually or very often used for organometallic reactions, for instance Grignard reactions. Then you choose diethyl ether or THF for the formation of the Grignard reagent. Therefore, there it's necessary that you have free electron pairs which coordinate to the Lewis acidic magnesium within that Grignard reagent. In some cases, it also works with this ether, MTBE. It has also free electron pairs, but here it is sterically hindered by the tertiary butyl group. Then we have dichloromethane. Well, a very good solvent, but because of environmental reason, one is trying to avoid that. Chloroform, the same, with the additional problem that this single proton here becomes rather acidic, as you know, with Potassium hydroxide, you can already deprotonate here, getting that anion, losing a chloride and forming dichlorocarbene and so on. Well, acetone, a very nice solvent. However, under acidic and basic reaction conditions, it will react by itself, with itself, aldol addition, aldol condensation. DMF, a very polar solvent, often used in palladium catalyzed reactions. It is somewhat toxic. It is rather difficult to get it dry, and it has a rather high boiling point. Afterwards, you have problems to get rid of it. The same is true for DMSO, but DMSO at least is of very low toxicity. It is often used also for medicinal applications. And not forgetting ethyl acetate, it is often the solvent of choice with a higher polarity in mixtures with hexane or petrol ether. You can adjust the polarity for your chromatography. So, and here we have a rather modern solvent, trifluoromethylbenzene. The disadvantage is it is rather expensive. Let's have a look at polar protic solvents. Well, water is such a solvent, and if your reaction is fine with water, well, why not using water as the solvent? Well, then we have methanol, we have ethanol, isopropanol. Lower polarity than ethanol, and I can say isopropanol is in my group the solvent of choice for trying a recrystallization. Somehow it turns out to be some kind of miracle solvent for crystallizations. And then, well, glacial acetic acid can be a nice solvent for, of course, acid-driven reactions. Thanks for listening.